Hello guys, we're from
Russel and Friends.
Uh, First, let us introduce ourselves. My name is Muhammad Riza.
My name is Brendon.
My name is Fastabiqu Khairin.
My name is Matthew.
My name is Deandra. My name is Hefty Clarissa.
My name is Yolita.
My name is Putri Amelia.
Today we are going to explain about multiple integrals.
Enjoy!
Enjoy your campus.
Okay, let's begin. First, what is multiple integral? Multiple integral is a definite integral of a function of more than one real variable. There are many types of multiple integral. One of them is multiple integral of two variables over a rectangular region. The double integral of the function f x y over the rectangular region R in the xy plane is defined as So, here is the example. We are gonna evaluate this multi-integral. 4 minus x squared minus y. We want to integrate the inner integral with respect to x, treating y like a constant. For x minus 1 per 3 x cubes minus xy
So now I want to explain about integral in triangle. Delta A equal R times delta theta times delta R. In here, R times delta theta describe arc length. S equal R times delta theta. Y on a polar theta is called rectangle because the boundaries are constant. And the constant is R is less than equal to 2 and R is more than equal to 1. And theta is less than equal to 2p and theta is more than equal to 0. So, in this picture, the boundaries are R equals sec theta, theta equal p quarter, and theta equal 0. So, we get this formula for integral in triangle. So, this is the example of integral in triangle. So, from the formula that we get before, we can put it into this example quiz. With restricted x-axis, y-axis, line x equal 1. And then we get this result.
So the next section is double integral over non-rectangular regions. For this section, you have learned the basic from the previous section, which is double integral over rectangular regions. So what makes it different? For rectangular regions, the range here at the upside is a real number, but for non-rectangular regions, it could be a function that represents the range. Let's move on to example number 1. Calculate integral of x squared dy dx. From the integral arrangement, we calculate the integral to y first. First, we focus to this side and calculate the function, so we have 3x cubic. Then we move on to the next step to integrate to x. So we got 3/4 x to the power of 4 with range from 0 to 1. So the result is 3/4. In example number 2, we need to find the volume of this non-rectangular shape. What we need to do first is finding the z function, the range, and the volume. First thing, we make the function of this region. We have 3x plus 6y plus 4z equals 12. Then we change this function to z function. With mathematical operation, we get z equals 12 minus 3x minus 6y divided by 4. Or we can simplify this to 3/4 times 4 minus x minus 2y. To find the range, we draw this region with xy coordinate. Then we get this triangle which represents the region. From the picture, we know that the x range is from 0 to 4 and the y range is from 0 to 2 minus half of x. Last thing, we find the volume by integrating the z function. We can find the volume by integrating the integration of 3/4 times 4 minus x minus 2y dy dx. From the integral arrangement, we need to integrate this function to y first. From the integration, we get 16 minus 8x plus x squared dx because we have moved the 3 divided by 16 to the outside of the integral. After integrating the function to x with range 0 to 4, we know the volume of this region is 4.
That's it.
That's it.
Thank you for watching. Don't forget to
Like,
comment, and subscribe.
Iya dah.